Hi everyone, I'm Jake. I run Mediaverse Studios, but I'm also a mechanical engineer. I've always loved building and tinkering with things, and lately I've been applying those skills to filmmaking. This series is all about the tips, tricks, gear, and builds that improve our lives as filmmakers. Welcome to Hardware Mode. In this video, we're talking about little lights. We've all used them. They're portable and they go anywhere. They're great to be mounted in a little hard-to-reach spot or under a lampshade to simulate a practical effect. You can give a little edge or be a little eye light. They're really handy and we love using these things on set. The problem with these lights is that they're notoriously difficult to modify. They come with their own built-in diffusion most of the time, but beyond that, there isn't much out there to modify this light in a way that we can kill off any spill or shape this light. In the past, we've used gaff tape or cinefoil in a pinch to shape this light and kill off any spill, but I wanted a more elegant solution. Unless you buy a dedicated light that has a pre-built modification on it, like an Aperture MC, you're not going to be able to find any products out there that can do the modification that we need. As a solution, I turned to CAD and 3D printing. CAD stands for Computer-Aided Design. It's a software program with a unique tool set that lets you design and create shapes in a virtual space. For the purpose of this video and this series, we're going to be talking about three-dimensional CAD. There are 2D CAD programs out there for drawing, but for building a three-dimensional object, we're going to stick with 3D. I use a 3D CAD program called Fusion 360. It's free with a hobbyist license and allows you to export an STL file into your 3D printer. A few hours later, you have something like this. This is a grid modifier that I designed and printed for this light specifically. This is a Ulanzi VL49. It's a RGB light that has a pretty decent output, but as you can see, has a whole lot of spill that comes off of it. So if we wanted to use this as an eye light, that's going to be very difficult without ruining the rest of the scene. So we just pop this on. It fits right over into the cold shoe mount and can also screw onto the mounting surface. And now you can see there's much less spill. And now you can use it as an eye light. So here it is with and without. Pretty big difference. And that's the benefit of modifying these little lights. I'm going to show you how I designed and printed this modifier, and then I'll design one for this light as well. I started by measuring and modeling the entire geometry of this light using a digital caliper. I like this one because it has a digital readout and is rechargeable. So you start by just literally measuring all the dimensions of your light, get the length, the width, the thickness, and any special geometry you're going to need. I chose to use this as a mounting point and this cold shoe as well, so I got the width of that. From there, we're going to go into Fusion 360 and we're going to draw it up. So I literally just drew a square and then offset that to be the thickness of my modifier. You can extrude it out like that. Now we have just a rectangle. And for the purpose of this build, I don't need it to be very aesthetically pleasing, so squared off corners are just fine with me. From there, I started drawing my grid pattern, and then you extrude that grid. So now we have three-dimensional grid. And from there, we added on the housing elements. So you can see here, I'm building out the thickness of it, and then I'm going to start adding in all the mounting points. So I started drawing the little stems and the pegs that the cold shoe is going to come off of. There it is there. And then I started drawing out the cutout for the mount adapter. So again, drawing rectangles and either extruding them in or out to add or remove geometry. Very simply, just by drawing squares and extruding them in and out, you can design a housing just like this, with exact dimensions for your specific light. This caliper goes down to 1/10 of a millimeter, so it's very precise. From there, you can just take the body that you created and save as mesh, and you can export that as an STL. So this program is called a slicer. This is emulating the build plate of the 3D printer, and there's a whole bunch of settings here you can use to customize your print. What we're going to do is take our STL file, drop it right on there. You can see that it's laid out. When you lay out your 3D print, you want to make sure the geometry makes sense. So I'm going to start by putting the flat end on the ground and then building up from there. So we're going to rotate this around. Right there. And you see it's going to snap to the bottom. And then it's ready to print. I'm going to make sure that I'm using the right kind of material. For this build, I use TPU. TPU is a flexible plastic. So you can see that this thing will rotate and flex. The reason I chose that is so that any sort of errors in the geometry or tightness is easily overcome, and it just is going to snap on and hug that surface. And now we're ready to slice and send it to the 3D printer. So you can see that it generates that tool path very quickly. It's going to take 2.5 hours to print, and you can send it right to the printer from your computer. And then a few hours later, you have this. It takes a little bit of cleanup in the end, but it fits perfectly, and it's durable enough because it is TPU plastic, and it's a very simple, cheap solution. So now I want to take a look at modeling and printing this one. So now I would like to design and print a grid for this light. We use this one as well. It has a magnetic back to it, and it's very handy to have around. So let's make this as simple as we can. We're going to start a new model in Fusion 360. We'll create a sketch. We want to start by modeling our rectangle. So we need a rectangle that looks like 39.3 wide. So we can just type in our geometry, 39.3, and it is 108.1 tall. So now we have a rectangle that is the same dimension as this light. We want to offset this geometry. We use this offset tool here and grab all the appropriate edges. And you can see that this offset tool is going to give us a wall inside or out. We want to go outside of it because it's going to be thicker than the light itself. And I think it should be about 5 millimeters thick. Oops, -5. So now we have a 5 millimeter wall. We can then extrude this wall out. And it needs to be, let's go with 29 millimeters thick. So now you can see we have a 29 millimeter rectangle. Great. Now we want to start adding in our grid. So to do that, we're going to do another sketch. On top of it, do a rectangle, probably, let's go 7 by 7 here. We'll do the same offset because we want the grid to have its own wall. And then we can extrude that rectangle up, probably, let's go 4 millimeters. There we go. Except I messed up. So we could edit this feature. Instead of joining, we want to create a new body, and I'll explain why later. So we'll create a new body here. And now we're going to use this tool, rectangular pattern. It's just selected the grid piece instead of the whole thing. That's why we chose new body instead of join. The axes, we want it to spread over the X and Y axis of the face. And now we're going to play with expanding this out. So I think if I go about 5 grids left and right over the course of, how wide was it? 30? Maybe 32.5? And there's no gaps. Perfect. So that's our x-axis spread. On the y-axis, we're going 108 millimeters, so I think we should probably go with like 12 or so squares. And 108 millimeters. How's that look? Oh, way too far. Let's go with 100. Very close. Let's go 13, 15. And to get that to the edge, we're going to go like 103, 102, 101. There we go. Yeah, great. Okay, so now you can see that this has automatically built my grid out for me, and we have a 5 by 13 grid pattern, and it has a thickness of 4 millimeters. Now, to combine all this together, we're going to extrude this edge up to meet that grid thickness, so 4 millimeters up. And now we want to select everything because we have a whole bunch of new bodies, which is each and every individual square is its own body. We need to combine all of these. So we'll highlight everything, modify, combine, and hit OK. So now we have one solid body that is the combination of all of these squares put together. And it's just as simple as that. That was just a few tools that you have available to you in Fusion 360 to quickly model up something. So I can take this, save it as a mesh, export it as an STL. So now we're back in our slicing software, and I'm going to drop on the modifier I just built. So you can see that the top of it is actually the grid. I'm going to flip this around because the way it builds from the bottom up, we don't want negative space beneath it. You can with a thing called supports, but if we can just move this around easily without needing supports, that's better. Will it go 180? What's going on here? There we go. Cool. And again, we're going to do TPU. We're going to slice it. It's going to take 2 hours and 40 minutes. So as you can see, there's a huge benefit to doing this DIY approach to your filmmaking gear. The benefit of DIYing your own gear is that you can fully customize anything to suit your needs and save a ton of money in the process. With the right skills and the right tools, you can come up with a solution for just about any problem you're going to encounter. So that's all for now. Thank you for checking out hardware mode, and I hope you learned something.